Today we're on the fourth type of word problem, and it's distance. All right. The fourth and final that we're going to be doing in class. Some students are telling me you're doing some of this in science. Yes, you'll notice how science and math kind of complement each other. All right. So what we're going to do is we need to read the problem. Who would like to read it for me, please? Go ahead.
Find the average speed of the barge in still water and the speed of the current.
Okay, good. So now let's talk a little bit about this. I've got a barge, right? And we have barges on our Mississippi River, right? And it's going against the current, which means which way is it going? It's going toward Red Wing, isn't it? Right? So it's going up, and as it's going against the current, it's going slower, isn't it? Because the current kind of pulls it back, right? All right, now if it's going with the current, it's going which way? Toward Wabasha, right? Yep. And as it goes with the current, what happens to the speed of the barge? It's going to increase. It's going to get more, right? All right. So what we're going to do first of all is we're going to come up with an equation, and this is the one that you're going to use to find the rate first of all. So D equals RT. And I know that D stands for distance. All right, I know that R stands for rate, and T stands for time. Okay. Take a look at upstream versus downstream. So this is the main information, and now we're going to use it. I'm going to first of all look at upstream. And then I'm going to do downstream. And I'm essentially trying to find the rate. Okay. So first of all, I got a barge that travels upstream 10 in 10 hours. So D equals RT. What's my distance? 25. My rate is, I don't know my rate. That's what I'm trying to find. And my time is 10. Okay? So how am I going to find my rate? What do I do here? I'm going to divide by 10, right? Because there's multiplication between the R and 10. So then the rate ends up giving me 2.5. And what would be my label? Miles per hour. Very good. Right, let's go downstream now. Same formula, D equals rate times time. How far are they going? 50 miles. I don't know my rate. What's my time? 5. What do I do? Divide by 5. So the rate is going to be 10 miles per hour. So that's how far this boat is traveling. Does that make sense? Okay. And notice that when it's going downstream, it's traveling faster, isn't it? Which makes sense because the current, it pushes it. All right. So I found the rate, but I didn't answer my question of the problem. Let's take a look at the problem. What am I trying to find? What does it ask me for? Average speed of the barge in still water. Okay, so like it was in Frontenac Pond and it was moving, how fast would it be moving, right? And then it asks me what? The speed of the current, right? That's how fast the water's moving. So I'm going to let x be the speed of the barge in still water. Is it important to put in still water? Yeah, it is. Especially when we're working with current, right? All right, and I'm going to let my y equal the speed of the current. Okay? Make sense? All right. So I still have upstream. And I have downstream. That's nice. Now let's talk a little bit about that. Here's the speed of the barge, yes? It's still water. What does the current do when it's going upstream? It's kind of pulling it back, isn't it? It can't go as fast. So it's pulling back on the stream, so it's minus y. And it's going to equal 2.5. And I got that from up above. See the 2.5 above? Okay, I had to find the rate. Downstream then is x. What does the current do? It pushes it, right? It helps it out. So rather than minus, I'm going to add. Yep. And that's going to give me what? 10. And I found that from up above. We okay? Make sense? Those are our two equations. So now we're going to use elimination to solve this. So x minus y equals 2.5. X plus y equals 10. Add or subtract? What do you think? Add. Okay, so x plus x is 2x. The y's cancel equals 12.5. What do? Divide by 2. X gives me 6.25 what? Miles per hour. Okay, what did I just find? Speed of the barge in still water. Yep, this is the speed of the barge in still water. Right now I need to find the current, right? So I'm going to take one of these equations. Does it matter which? No. I'm going to choose x plus y equals 10. So 6.25 plus y equals 10. Subtract 6.25. Y equals 10 minus 6.25. So y gives me 3.75. What? Miles per hour. What did I find? Speed of the current. Done. Okay. So to recap, what you need to do first of all is you need to find the rate. And you're going to always use D equals rate times time. Okay? So you find the rate with the upstream, you're going to find the rate with the downstream, yes? Then what you do, it's kind of a two-parter. With the upstream, it's going to always be x minus y, or whatever you define your variables as, and it's going to equal whatever you found up above. X plus y, the speed from up above. And then you just go ahead and then make sure that you answer your question with the label. We okay? Yes? All right, you got 2 more questions today in your packet. So if you will, go to your packet and let's take a look at 14 and 15.